Hi guys, I'm Niveta. In this video, we are going to see one problem based on net exam. Okay, wow. So it comes during June 2017 in net exam. Let A and B the sequence of real numbers. Okay, A and B the sequence of real numbers satisfying summation of n equal to 1 to infinity. Mod of an minus 1 is less than infinity. This is a condition which is satisfied by this an. Okay. Then the series summation of a n x power n x belongs to R is convergent. Then what they are telling is that series is convergent. Okay, wow. Then what we have to say is nowhere on R it is convergent, or everywhere on R it is convergent on some set containing minus open interval minus 1 to 1, or only on minus 1 comma 1. That is what we have to find. The answer is C. Let's see how we are arriving at the answer. So I'm taking an is equal to 1 by n square. Okay, so I'm just putting it in this format. Okay, so summation of instead of an I will be taking as 1 by n square minus an minus 1, I can take it as 1 by n minus 1 the whole square, right? So I'm just substituting these things. Okay, and then what we can take is I'm taking LCM. N minus 1 the whole square will come this side, n square will come this side. So when you expand this n minus 1 the whole square, you will get n square plus 1 minus 2n. Here minus n square divided by n square into n minus 1 the whole square will come. Then what? N square and minus n square will get cancelled. 1 minus 2n divided by n square into n minus 1 the whole square will come. Right? See here. Here we are having, in the denominator, we are having nearly n power 4 elements, because here we are having n square and here we will have like n square terms, right? So n power 4 elements. So it's like it will be like less than infinity. When you have a format like this, like when the denominator has a more power means, then definitely that sequence, okay, that sequence will be less than infinity. Okay, so what I'm trying to tell you is this 1 by n square is satisfying this condition, right? This 1 by n square is satisfying this condition. So I can take an as 1 by n square. Okay, first I'm considering whether it satisfies this or not, like that I'm just considering. But then I'm okay, yes, it's less than infinity, and I'm just taking 1 by n square. Okay, wow. So when that an satisfies this condition, that series, okay, well, that series will be convergent, right? That series will be convergent. So summation of, instead of an I am putting 1 by n square into x power n. Understood? So because I am considering an as 1 by n square, so when you want to find like summation of an into x power n, it's like x power n, instead of an I am putting 1 by n square. Okay, fine. Next, what I'm going to do is I'm going to check for the convergent everything, right? So I'm considering this thing as bn. Bn is equal to x power n divided by n square. So I'm considering bn plus 1 divided by bn. Bn plus 1 refers to what? X power here x power n divided by n square, right? Therefore x power n plus 1 divided by n plus 1 the whole square. So what will come? X power n plus 1 divided by n plus 1 the whole square divided by bn means x power n divided by n square. When you reciprocate it, you will get terms like this, right? So here if you cancel x power n, you will get what? N square into x divided by n plus 1 the whole square, right? Then when you substitute n tends to infinity, when you substitute n tends to infinity, in the denominator we have n as a infinity. Okay, so when the denominator has infinity means it's like the value should be like 0, right? When the denominator has infinity, the value will be like 0, so which is definitely less than 1, right? Which is definitely less than 1. So less than 1 means here modulus of x will be less than 1. Okay, so modulus of x means what? It will be like there is no equal to symbol, right? So we can't take a closed interval. So x belongs to minus 1 comma 1. Okay, so actually so we must discard this nowhere on R and everywhere on R we have to discard. Okay, then we have to check for this thing, some set containing this thing and only on minus 1 comma 1. These are the two possibilities, right? So and D is incorrect. why D is incorrect means if you consider x as 1, okay va. So x as 1, even though it is an open interval, I am considering x as 1. So suppose when you put instead of this x power n, I am putting 1 means what I will get, summation of 1 by n square will come. Okay, so summation of 1 by n square is also a convergent, right? So therefore we can't say it is only on minus 1 comma 1 because when it is in open interval we should not include that minus 1 and 1, right? So it's like on some set containing minus 1 comma 1. Okay, so please understand the question properly. Here I am having the sequence like a power n which satisfies these things, and then the series is convergent likewise. Okay, so what will happen? An is equal to 1 by n square. You have to, instead of this you have to substitute like this. You are getting the values like less than infinity. Okay, therefore for this sequence, sequence it is satisfying the condition. I am considering it as an, then I have to take it as summation of an into x power n. So I am considering it as summation of x power n divided by n square. I am putting like b power n plus 1 bn plus 1 divided by bn. Okay, in this format I am getting values like is less than 1. Less than 1 means what? Modulus of x less than 1 means it comes under like this. So we have a confusion like whether it's C or D, but when you substitute 1 here, we are also getting like when you substitute infinity, what will come? 1 by infinity will give you 0. That is also convergent, right? So when you consider x as 1, the thing is coming as convergent. So definitely on some set containing minus 1 comma 1. Thank you for watching.